Yeah, in your session, we will anyway do it. Just a second. Just give me a few more seconds. Let me the streaming start. Okay. We're good to go. We're going to leave the session totally to you, Samuel. You're going to decide how you want to take it.
Okay,
and
perfect.
the rest of you, Samuel, would you like to take questions while you're speaking, or would you like to take them at the end?
It depends. If it's a question connected really to what I'm showing and something is not clear, please ask right away. Awesome. If the question will be like too complex to answer, we will answer that at the end.
Awesome. Thank you so much. You can start.
Perfect. So let me share the screen. Can I share the screen?
Try now, Samuel.
I've made you the co-host. You can try now. Perfect. We can see it.
Perfect. Great. So let's start. It's like 1 minute before, but that's perfectly fine. Hi everyone. My name is Sam. I'm CTO and co-founder of Tatum. As you can see, ultimate blockchain development platform. And in today's session, I'm gonna show you who we are, what you can do with us, how we can help you with developing blockchain applications, etc., etc. So I don't have any strict let's say steps or things I will cover today. I was thinking about going through the onboarding to Tatum, which is very easy, and then I will use Postman as an API client, and we will go over some NFTs and something similar we have in the platform available for you, because I think that NFTs are one of the biggest topics these days. But it doesn't mean we do only NFTs, but I will explain a little bit later. So I don't know if it's going to take 30 minutes, 45 minutes, or an hour. We will see.
Please take your time. Please take your time. Don't worry.
I don't want to do so many stuff today because I know it can be overwhelming.
We can always watch your video again. So we are really looking forward. So I totally leave it to you. And if people find it tough, they'll always rewatch your video. Don't worry.
Okay, perfect. So I think we'll cover a lot of stuff today. Much more stuff is available on our YouTube channel, in our developer zone, where there is a lot of guides and tutorials what you can do with the API examples as such. So I believe this could be like a good start for you. So let's dig into it. It's gonna be a lot of that. So first of all, as I said, I'm from Tatum. We are doing a tool for developers, so you can build applications fast. By fast, I mean there was a project which was doing the integration in 4 hours, and he was able to support 5 blockchains in his platform, and these guys has no blockchain experience before. I mean that fast. So I hope it could help a lot of you, and we can see that right now there is more than 14,000 developers on the platform, and as far as I can tell, there is more than 3,000 or 3,500 active projects running on top of us. So I believe what you can do is quite powerful with us, and I know that some projects literally wouldn't exist without our platform, because we have support for over 40 blockchain protocols with a lot of abstraction on top of that. But let's get to it. First of all, what you need to do, you need to sign into our dashboard, where you can create API keys. API key is key you will use for communicating with our platform. Our platform is a cloud-based REST API service, and we have, except of the APIs, we have a couple of SDKs and tools around the platform which can help you with security, with custodial wallet management, and many more. but like the core right now is the API platform, and you can create up to 3 free API keys. API key is the free one is unlimited use in terms of the consumption, so you can use as many API calls as you want. The only limitation is 5 API calls per second, so it's ideal for basically any ideation phase or fast MVP or just playing around and to see what the platform look like. And if you want to go for production, you have 200 API calls per second with some credits you can use. Right now, you can choose. We can choose which plan we want to go for, and you can choose mainnet or the testnet of the blockchain you will working on, and the region. We are supporting 2 regions right now: Europe and the US West. We will add more regions in the next couple of months, I hope. I can't create new API keys because I have all of them. But when you create one, you can just show the API key and you can copy that and use in your HTTP request to the platform. So go to Tatum.io, sign into the dashboard, grab an API key, and you can start playing around with the API. Regarding the developer zone and things you can do with the API, we have quite nice learning section where you can just read through the basics or just jump right into the more complex issues, like how to build custodial wallets, how to use MetaMask with Tatum, how to pay fees for token transfers, or so many other guys, how to create tokens, NFTs, etc., etc. In each of these guides, usually there is either video we have done in the past, or there is a Postman collection available where you can just download all the API calls ready for you and just go. And the video is on our YouTube channel where you can find all other videos we have. The videos are usually, as we will do right today, so step-by-step guide of step-by-step guide connected to the topic, like NFTs or custodial exchange or anything else. So there is a lot of stuff you can read, you can watch, and let's dive into the actual using of the platform, and let's use the Postman. And I will today, I think what's the super easiest way for us. I have been doing some workshops lately where I was demonstrating the platform. I was doing the workshop for a Celo blockchain. I was doing a workshop for a Flow. And I think the structure of these workshops was quite nice, and we will reuse it today. So I will give you brief introductions to a couple of the topics or sections we have here, how to work with the basic blockchain integrations, how to work with different DRC tokens, either fungible, non-fungible, or semi-fungible, how to play around with the IPFS, which we support in a platform natively, and you don't have to do any other integrations. And what's even better, you don't have to pay for the IPFS storage because the storage is being paid by our partner, NFT Storage. And I believe I will show you maybe the gas pumps virtual account. We'll see how it goes and how exhausted we all gonna be at the end. So as I said, today we're gonna work with a Celo blockchain. It's a EVM compatible proof of stake blockchain, quite popular recently. We have nice partnership with them. But among the blockchains you can use in our platform, there is also like Bitcoin, Ethereum for sure, and for EVM chains where you can play around with the different type of tokens. It's Polygon, Celo, Binance Smart Chain, Harmony, Tron, which is also popular. We are adding new chain on average once in a month. Our recent additions were Algorand and Elrond. We are working on Solana and Clayton and some other chains which are popular in the NFT space. So I believe by the end of this year we'll support 2 or 3 more, and you can play around with NFTs as well. And maybe just go back to the basics, what we are trying to achieve. We do support like 40 different chains, but what we want to do, we want to make the development simple. And to make it simple, we have created, I think, 3 levels of the API inside our platform. These levels are different levels of abstraction we are giving you to work with. The first level, the very basic one, you just call the native Web3 calls for Ethereum, for Celo, for Polygon, for any chain out there, which have some kind of native RPC or RPC API. You can always use that. So if you are used to work with, I don't know, Infura for Ethereum or any other provider out there for any chain, or with your own node and you are running your own node, you can always use our API in this, let's say, most basic integration. You just call the API from the node. The second level of abstraction is something which is sitting on top of these node APIs, but it's still, let's call it the native blockchain. What I mean by that is in this blockchain section, those are the endpoints like get current block, get block by hash or by height, get transaction, I don't know, send transaction or get nonce. These type of operations which are like natively available in the Node API, but we have done a small abstraction and create, let's say, a simple unified endpoint for you. By unified, I mean you will find the same get block operation in Celo. You will find the same get block operation in Ethereum, in Binance Smart Chain, in Bitcoin, in Litecoin, in whichever chain we support. These, let's say, the level 2 abstraction endpoints are there available, and you can use them. So we have done one step further towards the simplification and prepared some stuff for you. Also, this kind of abstraction is quite popular because some developers, they are using it a lot when they want to do native, I don't know, scanning of the blockchain and want to see what's going on, what's the blocks, what's the transactions, whatever. But it's not yet the end game, and it can be simplified even more. And this kind of simplification, this third level of abstraction we have prepared, we call it virtual accounts. And by these virtual accounts, I mean, you just create one totally anonymous account, let's call it account, and you say that this account will work with Bitcoin, this account will work with Ethereum, with Litecoin, with whatever. So we have only one unified way of creating accounts, and you can attach different blockchain addresses to this account. And you can scan for incoming transactions to this account. You can send outgoing transactions from this account, and you don't care if the underlying blockchain this account operates on is Bitcoin or it's Ethereum or it's Solana or anything else out there, because we have done all these, let's say, the boilerplate code and hard integration through blockchains for you, and you just utilize exactly the same API methods and API calls. You just call create account, and you can call it for Ethereum or Bitcoin or Litecoin or Binance or Solana or whatever out there. You don't care what's below. You don't care how addresses are generated. You don't care how transactions are being signed. You just use the same integration to any blockchain we support in this stuff. There is. I will open the chat. There is a question in the chat. Hi Sam, so developer app is calling the same API just with the name of blockchain without knowledge of practical blockchain codes. Yes, exactly. You don't care what's below. You just call the API and we do the translation below. So we have these three levels of abstraction, and you can always choose which one you will use and which one is you are convenient, you are like okay with. And I'm going to go over each of these each of these levels of API today, and I will show you some basic operations and what can be done with our API. So let's start with this. Let's go native blockchain calls. We always have it inside the blockchain section in our API documentation, and the most simple one is the Web3 call. That's like you can't do anything less simple and anything less native than this native Web3 call, where you just call the RPC method to the node, for example, get client version, and you just receive the result. Nothing more. You just use all the Web3 methods available in the blockchain you want to work with. The same applies for Ethereum, for any other EVM compatible chain. For non-EVM compatible chains, for some of these chains, we do have this endpoint. For some of them, we don't. It depends. It varies. But if you are like a skilled Web3 developer and you don't need anything else out there, you build everything by yourself and know what to do, that's perfectly fine. And you are just looking for a way how to, for example, scale your business, and you are looking for external node provider or something like that, you can leverage this kind of endpoint, and your application, if it's done, you can just migrate to it in 5 seconds. But this is, let's say, boring. This is boring from our perspective and from the platform perspective, because you don't use any, let's say, advanced features. You still need to reinvent all the invented stuff. So you need to, for example, scan for blockchain transactions you are interested in, and I don't know which other things, but you still have to do it by yourself. So there is another level of the abstraction. So let's go one level up. And let's take a look on these get block and get current block and get transaction operations. Those are also leveraging the blockchain node, but we have prepared something. So for example, we can see that the current block number for a cell or testnet is this one. We can get a detail. We can get a detail of this block, and we will see this is the block data. These are the transactions available in present in this block. So you can just fetch the data very, very easily, very quickly, and in a convenient way. We don't do any modifications as a platform to this data. What we receive from the node is what you are receiving as a response. So we are not, for example, fetching some events or logs for a transaction where events was present. This is the very basic get block operation with a list of transactions, and that's what you are receiving. Nothing more, nothing else. But still, it's something you can find very useful, especially if you are doing some very fast POC or MVP and want to very fast integrate something and see what's going on in a blockchain. You can just call get block and see the details. It's very nice. What's not present in a blockchain node, but it's very, let's say, without that you can't build any blockchain application, is how to create a wallet, how to create your private key, how to get address for that private key, and how to send some assets from that address. Without these like 3 or 4 operations, you can't do anything on the blockchain. You can just do a dummy read, which could be nice for some projects. It makes perfect sense. But if you want to do something for your users, you need to create wallets for them. So for each blockchain, we do have APIs available for wallet generation, for private key generation, for address generation, for transaction signing. And yes, we have it on an API level. So it means that your private keys and mnemonics are traveling on the internet, which is not good. You should never have that set up in your production application. You should never send your private keys away to any like third-party solution. And also you shouldn't generate private keys somewhere on the internet and just receive it as HTTP response. It's not safe. It could lead to huge loss on your side. But we have these endpoints available for you. Usually for these kind of workshops, I'm having 4 MVPs for super quick POCs of something where you can just generate wallet address, private key, and that's it. But we do have Tatum CLI command line tool where you can locally generate this stuff, or you can use Tatum KMS, which is a key management system for custodial providers and operators, where again, on your end, you will just generate everything locally and sign everything locally. And we have a client SDKs where, for example, for JavaScript, you can include our JavaScript library in your backend, and you can generate the private keys in your backend or in your front end if you're building a non-custodial solution. So everything is out there. Don't use APIs, just take a look how it behaves and what's behind it. And if you want to generate, so let's just generate the wallet for a Cello. There is a question from Osama, can be used to build a private blockchain, or through integration can build a wallet for the current private one? Do you have a private blockchain like on like Quorum or private Ethereum or something Ethereum compatible? If so, the API could be used with the private blockchain as well. We do have support, for example, for your private Quorum, and you can connect these methods to your private Quorum instance. Yes, it's possible. But wallet generation on Quorum is exactly the same as on Ethereum chain because the addresses and private keys have the same format. But you can perform transactions on the Quorum. Yes, it's possible. It's available in our API documentation. You can check the Quorum section. So let's generate the wallet. Let's generate the wallet, and by wallet we understand HD wallet. So here he called deterministic, I believe that's the correct wording for that, which means you have one mnemonic string, which is usually 24 words, depends, sometimes it's 12, sometimes 25 based on the chain. And this mnemonic holds all of your private keys and all of your addresses. And from one mnemonic, you can generate up to 2 billions of different private keys and addresses. But they all are, let's say, restored from one mnemonic phrase, which is super powerful, if you are building, for example, some custodial solution. You don't have to store on your side 2 billions of private keys and addresses connected to your users, which is super wrong. And from the security perspective, it's just a mess. But you can have one mnemonic and you can obtain any private key and any address from that. Yeah, it also has downsides. Like, yes, what if I lose my mnemonic, all of my accounts will be at risk? Yes, that's the case, you're right. But it's always easier to make one thing secure enough than to make 2 billion things secure enough. So what I see in the projects out there, they are usually using mnemonics and they make it as secure as possible. And alongside the mnemonic, we have received the XPub, which is extended public key, and this XPub is basically a read-only generator of addresses. It's connected to the mnemonic. It's just one piece, obtainable piece of information from that. But with this XPub, you can generate addresses, and it doesn't contain any information about your private keys. which is great because you can use this XPub in let's say not so security sensitive environments, and you can generate addresses from it, which is perfectly fine. For example, somewhere on the application server where your application is running. Yes, it also XPub should be secure, but it doesn't have to be as much as mnemonic. And if someone just get to your XPub, he can generate only addresses, not the private keys. But there are still situations when someone loses private key, address, and XPub, and it can find all private keys out there. But it's like, again, super crazy scenario, and you should be very, very aware of the security of your XPub as well. But if you want to generate address for a Celo from the wallet, we can use the XPub we have received, and we can generate address number 0 from this wallet, or we can generate address number 1, or we can generate address number, I don't know, 1 million. We can generate as many addresses up to some reasonable number as we want from one XPub in one operation, which is great, and we all have these addresses available. If you want to generate private key, we need to pass the mnemonic inside the request, and again, index of the private key we want to generate, and this is a concrete private key to a concrete address out there. So I believe you have right now the 3 pieces of this stuff together. We have wallet. From wallet we generate address, we generate private key, and address is obtained from XPub, and private key is obtained from the mnemonic. That's everything we need to know. This approach we are trying to follow in each blockchain we are integrating, and in each chain where it's like technically possible, because some of the chains, they don't support this concept, so we don't support it as well. But if the blockchain supports that, we are trying to support it as well. There is question from Osama, can we use to scale the number of transactions per second to be more than 7 for BTC? Yes, we will get to it later, but yes. So we do have address, we have private key. What we can do, we can send, for example, we can send some assets to the blockchain from one address to another one. And the endpoint is usually v3/blockchain you want to work with /transaction, and you choose the currency you want to send. Right now we are sending Celo. How much we want to send, who's the recipient, what's the private key from which the assets will be deducted. And Celo has a very nice feature that you can pay for transaction cost with the stablecoin they support. So for Celo there is additional fee currency field here, and let's send some assets away. The result is a transaction ID, and we can check this transaction ID in their testnet explorer, and we will see that we have sent 0.09 Celo tokens from my address to another one, and we have paid the transaction fees with the stablecoin Celo dollar. What we have also done in this let's say level 2 abstraction methods is something which is not natively available in the node, and it's a simplification of interacting with the smart contracts on the blockchain. So if you want to interact with a smart contract, you need to create some crazy logic in your application code using either Web3.js or any other library out there for the language of your choice. But we have done it on the API level, which is much easier for you and in terms of the integration. And you just need to enter the address of the contract you want to interact with, choose the method you want to invoke, pass the API of the method you want to invoke and the parameters of the method. This is the read-only method balance of where I'm checking how much assets of how much like ERC20 assets of this contract I own in this address, and the result is I own this amount of these assets, which is, I believe, $SEL or SEL euro stablecoin on their network. You can also perform not read-only methods, but also the write methods like transfer or invoke any like DeFi contracts out there on the blockchain. If you have the API for the method you want to work with and the contract address, you can call any method out there on any smart contract, which doesn't even have to be yours. Again, we do support the smart contract invocation for every blockchain which has smart contracts. Right now, it's like 6 or 7 in our platform, and you can work with anything out there. So if you are doing some kind of cross-chain or multi-chain DeFi app, and you want to, for example, communicate with Uniswap on Ethereum and on Polygon, and some PancakeSwap on BSC, and do some kind of arbitrages, this is very handy because you can just call the methods you need for each chain out there. There's a question. How can I get solo coins on my test wallet? Okay, I have skipped this. I have skipped this session or this section in this session. So if you generate the address, for example, we have generated address 1 billion. We receive the address, and Celo has a nice faucet. Usually every blockchain, every testnet version of every blockchain has some public faucet, which is site where you just enter the address you want to work with, and you receive some assets on the testnet. So it's very handy. You can find it also, for example, for Polygon or for Binance Smart Chain. You can receive basically any testnet versions of any coins out there. Otherwise, you can't work with the testnet chain. For example, it's quite hard to find working Bitcoin testnet faucet because there's not so many like live and funded faucets out there, but it's doable. But for these EVM chains, it's very easy to find working one. That's not a problem. Okay, so we have received for sure some assets in this address by now, and we can see that on Celo they have sent us 5 Celo, and they have sent us 10 Celo dollars and 10 Celo euros. They're stable coins which are available by default in their chain. Okay, so we have covered basically all blockchain section I have prepared for you. There is for sure many more endpoints available. You can check our API reference, and you can see all our endpoints with all inputs and all outputs and example data and some additional explanation in our API documentation. You can also download the OpenAPI spec if you want to generate some client on your side to easily work with that. And if we find a blockchain Celo section, you can see there is much more stuff than that I've shown you. For example, get balance or get transactions by address or get transaction details and many more. You can check all other chains. There is a quorum, as I was answering a couple of minutes ago, and there is basically any chain documented here on the left side, and you can find it. So what's ahead of us? Ahead of us, there are tokens, and these tokens have very, let's say, similar approach in terms of integration. We're trying a lot to make it as easy as possible for you. Many of you know there is plenty of different types of tokens and standards out there, but the most let's say, common these days are ERC20, which is a fungible tokens. Basically, any coin out there is ERC20, any payment coin or anything which is like tradable on an exchange is ERC20. It's like USDT, USDC, basically anything. So these are the fungible tokens. I believe all of you know that fungible tokens, each of the tokens is the same and they are not distinguishable from each other. Then there are ERC721s, which is a standard for non-fungible tokens. So there is always only one of that kind token out there. And then there is ERC1155, which is semi-fungible, which means you have a specific token ID, but you can have as many copies of that unique token as you want. So again, use cases for this is very popular in the NFT space. If you are creating some kind of drop with NFTs, and each of the NFTs should have, I don't know, 50 editions or something like that. So we will cover these three topics right now. Maybe before that, I will show you how to work with the IPFS, because it's important part of the NFT space and NFT ecosystem these days. Because NFT, what makes NFT and the unique and expensive stuff out there? It's not the token ID on the blockchain, it's not the contract address on the Etherscan, but it's the data attached to that token. And this data should be, well, for NFT must be stored somewhere where they cannot be changed, they cannot be modified, they cannot be deleted. So you can't store your NFT metadata on S3. Well, you can, but it doesn't make any sense, because when you delete the data on S3 or you change the data on S3, the token on the blockchain, it doesn't know that anything has changed and that anything is wrong with the data, and the owner of the NFT doesn't know that the NFT is not the NFT he bought because someone changed that. So in order to avoid these situations, you should store the data ideally somewhere on a decentralized storage where it will be forever, where it won't be changed, modified, or altered or deleted. Most used decentralized storage for the NFT data these days is IPFS, Interplanetary File System, where you can upload any data you want, but you have to pay for the data on a monthly basis or daily basis. And those data are there, available, can't be changed, can't be modified. But once you stop paying for the data, or you unpin the data from your local IPFS server, those data will be deleted and lost. That's honest to say, and say loud. Those data are there, available, but if you stop paying, you lose your data and your NFT is gonna be like worthless, which is somewhere like halfway to where we wanna go regarding the NFTs. Some projects leveraging, I don't know, Filecoin these days, or ARView blockchain for storing the data, and those data are available there forever. It's a little bit more expensive, but you need to pay for the data as well. But in the IPFS space, there are guys, NFT.storage, who are like, let's say, a gateway to the IPFS space. And they are paying for the data to be pinned forever. It means your data will be there forever, and guys from NFT storage will take care of that, and they will take care of the payment and of presence of the data inside IPFS. So you can very easily just store the data to the IPFS, don't care about paying, don't care about pinning and unpinning and all this stuff. You just store the data using our platform, which integrates them, and we have a very nice partnership with them. And you can then get the data back from the IPFS as anytime. And these data are then usable in your NFT, or ERC-155, and you can connect your token to a specific decentralized data out there, which makes the NFT, not just the pointer to your internal database or something like that. So if you want to store anything in IPFS, you just need to choose the file you want to store. I don't know what nice I have here. That's I won't store. I won't store that, but I can store, for example, this nice image, and I can send it to the IPFS, and as a result, I will receive the IPFS hash, which is the some kind of unique identifier on the IPFS network. And when I want to read the data from the IPFS, I will just reuse my IPFS hash, and I will read the data, and I have received them. With this hash, you can go to any IPFS Explorer. You just enter the hash. I think this one they don't support. Not all IPFS Explorers has support for every IPFS records, because there are specific gateways and they decide which content they want to support and which content they don't want to support. IPFS Explorer, let's try a different one. Not this one. Another one. Okay, I will send you the link after the call. I don't want to waste time here, but that's the logic. You just generate the link to the IPFS and store it to the token. So that's simple it is. For now, we support files up to 50 megabytes big if you want to store. So basically for any NFT of reasonable size, if you want to store images or small audio, it's possible. For videos, you need to do your own direct integration of IPFS or anything decentralized out there. We don't support these big files to be stored, but for reasonable amount of data, it's just fine. So let's go for ERC-20. Basically, most of the projects I've been talking to last couple of months either had to create their own ERC-20 token, or they have used existing ERC out there. The projects that I'm talking to are different type of NFT marketplaces, different exchanges, different wallets of any kind, or anything out there, and they have touched ERC in some manner, every one of them. For example, some of the blockchain games or NFT marketplaces which are being built on top of our platform are creating their own ERC-20 tokens, and they are using that token inside their marketplace as a payment currency on a blockchain. Some of the projects are just integrating, for example, USDT or USDC or any other stablecoin out there, and they just allow their users to accept the stablecoins and send it away, and basically a simple wallet. They can pay for whatever they want. But in any case, you need to know how to work with the ERC tokens and what to expect from it. We have if you want to create your own token, your ERC-20 token, like in a basic or first initial setup, what you have to do is you need to create your own ERC-20 smart contract in Solidity. You need to know what to do. Yes, there is so many templates out there, or there is so many, for example, OpenZeppelin has a really nice palette of smart contracts available for you and for your use. But you still need to touch Solidity somehow. You need to compile it, you need to deploy it, you need to test it, you need to do all this stuff. And for most of the developers who are let's say, blockchain untouched, this is too much, and they just give away, and they won't do that because it's super hard and super complex. Even for a skilled Solidity developers, some of the smart contracts out there, I'm saying the ERC20, but for example, more complex one, like some DeFi or marketplace stuff, it's a lot of code, and it's a lot of things you need to cover on your end from the security perspective and from the gas optimization perspective, etc., etc. So what we have done in our way to help developers develop fast, we have prepared these templates for you. You can always not use them. You can use your own one. But if you want to create the ERC20 token super fast with the basic setup, you can just use our template, which is available open source out there on our GitHub, and you can just deploy it. You can just reuse it, deploy it to the blockchain. You just choose the name of the token you want to create, symbol, the address of the initial supply, what's the initial supply, if the token should be kept, what's the total cap of the tokens, how many digits it should have, and blockchain you want to deploy the token to. You can see right now in the URL there is no like chain identification. There is just the very, let's say, general blockchain token deploy stuff. So if you want to work with Celo, you use Celo, or you can use Ethereum, Binance, Polygon, I don't know what, Algorand, Solana, any chain out there which we support. More chains we will integrate in the future with the ability for ERC20 tokens. We will add it inside this abstraction. So this is also the highest level of abstraction for you, where more chains we support, the integration will always be the same, give or take some optional parameters for a specific chain, like the fee currency in this case. So let's create some demo token out there on the blockchain. As usual, the result is transaction ID. If we check this transaction on the Explorer, you can see that we have created 10, I don't know what, billions, 10 billion.
Samuel, I had a question for you. How do we pay the gas fee for creating tokens on the production mainnet?
Yes, it's a optional parameter where you just set your gas limit and the gas price. For example, I don't know, 6 million gas limits, and then the gas price could be 20. It's optional. If you don't provide it, we do the calculation of the current gas price and do the estimation of how much the transaction will consume. And this applies for any type of transaction, also for native send, for 7-to-1s, for anything. The fee is always optional parameter. If you don't provide, it's auto-calculated.
And where do I have to store the coins to pay the fee? How do I link that to my Tatum account?
The coins are always stored in your private key because your private key is connected to the address.
Okay.
So you will use your private key from which you want to pay for transaction and from which you want to deploy the token.
Perfect. And would this go over SSL or it goes over HTTP? I like HTTP or HTTPS?
It's always HTTPS.
Awesome. Awesome. Thank you.
But as I said before, this private key stuff here is only for demo purposes. You can leverage our SDK where you will sign the transaction locally and you will not send private key to our side. Or you can use our key management system if you're a custodial provider where the private key is stored somewhere else on your system and it doesn't touch anything else than your system.
Got it. Thank you.
So we have created a token. It should be here, Tatum demo token. It's nice. And we have sent all these initial supply to this address. Perfect. Right now, what we can do, we can transfer basically any token we own, again, in our private key on a Celo blockchain with this amount of digits, this amount of assets. This is the contract address of the token we want to send away, and this is the recipient. So we have created token BFE9, etc., etc. It's present on this address 80D because that's the address in my private key connected to it, and I wanna work on a blockchain. Celo, I will pay for with Celo USD for a transaction fee, and I'm sending 0.009 tokens from my account to someone else. Did I use the correct chain? I don't know. Correct number of assets. Tatum demo tokens. Okay, I will double check. Maybe I will revert to the existing one I was sending. Okay, I will check that later why the address from the previous deploy wasn't working, probably some wrong configuration on my end. But if we take a look on this transfer, I was transferring Celo Euro, which is also ERC20 token. I was sending 0.009 tokens from myself to someone else. Of course, there is much more endpoints than deploy and transfer in the ERC20 section. You can, it's present here in the fungible token. You can mint the tokens, you can burn, you can do approval of spending of these tokens on behalf of someone else. You can get ERC20 transactions by address or get an account balance of that specific ERC. So right now I have here only two stuff, and in the transaction API, what I have prepared for you as well is a couple of methods. I can get a detail of the transaction, basically any transaction. Right now it's Celo, and I can see the details of the transaction. This was the deployment transaction. In this get transaction details, there are also logs present there. So each event that the contract emitted is present here, and etc., 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 etc. Some kind of status and other not important stuff from the transaction. We have also prepared handy endpoint for you, some kind of a utility endpoint, where if you are performing some deploy transaction, deployment of ERC20 or NFT or some on-chain marketplace or auction, you just enter the address of the chain you want to work with and the transaction hash, and we parse automatically the address of the contract from the transaction. Again, very handy endpoint if you are building application where you are programmatically deploying a lot of contracts out there. Very, very, very handy. And then there are, let's call it analytical endpoints for you, where these data which are obtained from these endpoints, these data are not available in a native blockchain node. If you run your own node, you won't have these endpoints for you, because the blockchain nodes, they don't do indexing of the transactions and they just don't do any analytical stuff on top of it. All of these informations are indexed and scanned by us in our systems. We are scanning, I don't know how many chains. We have terabytes and terabytes of data from different chains scanned in our systems. And we give you some handy endpoints for seeing what's going on out there. For example, for this blockchain address, I can get all transactions incoming and outgoing, which has been like invoked on this address. So some from, or where the address is in a from or in a to fields. So anything incoming or outgoing are present here. Also, what's available is find all ERC20 transactions for a specific address of a specific contract, which means if your address was involved in transferring ERC20 tokens, in minting, in burning, in anything out there which make the tokens move from address to address, this endpoint will give you the details. And again, it's unified in a blockchain token transaction where you just put the chain address and the contract address, and you can see that this token XFE, etc., 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 was minted to your address, and then we have performed some transfer from my address to another one. We can check. I think this I was doing on a previous Celo workshop, and this is some testing token out there. And you can see that there was just a contract creation and transferring of the tokens. So 2 operations available here. So these endpoints are really, really handy, because if you want to have this data by yourself, you have to scan all blockchains block by block, transaction by transaction, and just collect this information somewhere in your systems. For one chain, one smaller chain, yeah, that could be doable. If you want to go with, for example, in Polygon or BSC, this is not so easy, because the data out there on these chains are like extremely large for now, and the blockchains are fast. They are creating blocks each 2-3 seconds, and in each block there is hundreds of transactions. So just the computing power for getting all this information from the node, parsing them, processing them, and storing in your system, it's quite big and it's quite complex. So, and this is just one chain. And if you want to build multi-chain hub or where you will support 5, 6, 10 blockchains and do the same indexing of this data for all the chains out there, and sometimes they are completely different in terms of architecture. Bitcoin is completely different than Ethereum, and Bitcoin doesn't have these native get transaction by address calls as well. In some like newer nodes, yes, but in general, it's not part of the protocol. It's always part of some kind of additional value the node gives you, but it's not so easy to maintain. But you have it available on our end for you, and we do it just for basically all of the blockchains where it's possible. Some of the blockchains, they give you this information out of the box. For example, I don't know, on Stellar or Algorand or Elrond, they have the endpoints available in the node, or they are shipping their own indexer alongside the node where where the indexer is indexing the data like automatically. But these, let's call it older chains like Ethereum and Ethereum base, you need to do it manually by yourself. And the node will never, ever, ever do this kind of integration to the node itself, because the node is super happy that it's able to keep up with the network, especially for BSC. For example, BSC has hard fork next week, and most of the node providers out there for BSC are crying because it's not possible to keep up with the blockchain and to rescan the new node, because they have done some not so good rollout of the new version of the node, and it's really crazy. So the node can't keep up basically, and and the node will never index the data if it can't keep up with the network SR, because the computation power needed for that, it's like tripled. It would be tripled for where it's now. But let's go back. So these were ERC20 tokens. Very used basically everywhere out there. Anyone has some experience, I would say like 100% of you. Next two topics are 721 and 1155, basically NFT standards. I don't know about any other standard in Ethereum-based chains which is being used for NFTs these days. I think only these two, the coverage is 99.99%. So everyone is doing their own NFTs using either the non-fungible, where one token is only one and forever, or semi-fungible, where one unique token can have 50 different copies or any amount of copies you will use. Again, deploying is has the same mentality as for ERC20, name, symbol, chain you want to operate on, private key from which you will be able to mint in the future because that's the default minter. And the template we have right now doesn't allow to mint new NFTs by anyone out there, only a specific address with a minter permission. So let's deploy NFT. We have a transaction. We can use our get contract address from transaction endpoint. We have a contract address of a transaction, and let's mint new NFT. This mint operation is actually where you are creating your token. This is the place, not the deploy. Deploy just deploys the contract, which is there, but it doesn't have like any value. It's just the contract. The token as such is the one important. So we are minting new NFT in this contract. Token has ID number 1. It must be always numerical ID for NFTs. Working on Celo, this is the private key from which we will pay for the gas cost and which has the minter role available. We are paying with the Celo as a fee currency. We are minting to this address. And this is like the most important part of the minting of the NFT operation. This is where you're attaching your metadata to your NFT. This is where you are telling this NFT will have value, and the value is based on this information I'm putting here. So this URL should point to the metadata JSON scheme out there somewhere. And the metadata JSON scheme has a very simple format. It has by default 3 fields. The field is a name, description, and the image. And the image itself is the URL of the content you are putting. The metadata scheme is quite old. That's why there is image, and you can mint audio or video right now very easily, but you are still putting it to the image field because of the backward compatibility. But you are not putting image directly to the NFT. You are putting the JSON metadata to the NFT, which points to the image or any content out there and describes the NFT with name, description, and some additional fields. For example, OpenSea, they have, I don't know, 10 or 20 additional properties in the metadata scheme they are working with and they are reading. So let's use the IPFS data, the IPFS identifier as our metadata on the Celo, and it means we have to upload some metadata file to the IPFS. So let's just create one. It's nothing complicated. It's basically a JSON where there is a name, there is a description, and there is an image field. And the image field, let's use this image we have stored before, and we are creating an NFT for this specific image. Always put your IPFS identifiers in your NFT with the IPFS prefix. Don't use some publicly available links to the explorers or anything else. use IPFS with the ID of the record. Each client should like work with this IPFS prefix out of the box. If not, it's a shitty client, but OpenSea and anything else is working just fine. So let's store this metadata JSON, store it in my documents. And when I mint NFT, no, before I need to put this metadata to the IPFS. I have received a new identifier of the IPFS record, and I'm minting my new NFT with this metadata built in. Perfect. This is the transaction ID of an NFT mint operation. When we check it inside the Explorer, you can see that I have minted token number 1, which has this metadata information available. The Explorer, you can see that Explorer reads the information from the IPFS out of the box, and I have minted a token to some address, and I can see this is the metadata I have attached to the NFT. Again, very, very, very simple integration. We've been trying to do that as simple as possible. But what we have seen in other projects out there, they want to mint 1, they want to mint 2, they want to mint 1,000 NFTs per second, or they want to mint a lot of NFTs, and they can't use the 1155 standard because those are different NFTs. By default, the ERC-721 standard doesn't support something which we call batch mint of NFTs. That functionality is just not there. So in our template, we have added this batch operation of NFT minting, and you can see you can mint as many NFTs with different token IDs with different URLs to as many recipients as you want on one specific smart contract. So let's use our new contract we have deployed, and let's mint this huge amount of NFTs in one operation, which means one transaction ID contains all these NFTs, and we can see this one. And you can see that we have minted so many NFTs right now in one operation. Like, I don't know how many, huge amount of them. Yes, the transaction gas consumption was higher, but it's still lower than if you would mint these NFTs one by one. It saved you, like, I don't know, 100 transactions on the blockchain, which is extremely important for high throughput projects out there. For example, if they want to really mint, we have one project, they are minting NFT each time new user signs in, and they had like 30,000 signups per day, like in the day 2 of their launch. And if you calculate how many transactions you need to perform and how much time you need to wait for each transaction to settle on the blockchain, 30,000 a day, you would process just 2 days, these 1 day. It's basically not possible to just keep up with the minting from your end without the batch. With batch, they are super happy. They were able to reduce the number of transactions from thousands to hundreds per day, which is perfectly scalable for the future. Question is, how many languages do you have the library to perform these API calls, if any? We have available JavaScript library. I think C# is done these days. We have Python, which is not so up to date. No, not all endpoints are there. We are working on different languages, but our priority right now is JavaScript one. It's always up to date with the latest versions, and we'll see how it goes. Okay, so this was Mint, multi-mint, and also we can, of course, transfer the token from me to someone else. Token with on a specific contract address and with the ID. Another useful endpoint is to get the metadata of the token programmatically, which is some kind of, let's use this one, where we have used the IPFS. And you can see that you can always read the metadata attached to the token. When we go back to the transaction section, there are useful endpoints like get 7-to-1 transactions by address. So you put there one address and the contract address you want to scan, and you will see all NFT transactions on this address. So any mint, any transfer, any of the tokens for your address. You can see we have been minting token number, blah, 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 to myself. We were transferring this token number 1 to someone else, etc., etc. So if you want to create some kind of super easy explorer for different chains or for different types of transactions, you can easily leverage these operations. Also, what we can find here is to find transactions for a specific token. For example, my token was minted to this address, it was transferred to another address. There is get transaction by token ID endpoint, and you can see here as well that the token was minted to this guy, and this guy has sent this token to someone else. And right now the token is sitting on this address. So these are the 7-to-1s, and 1155s are basically the same type of integration. You just deploy the token on a chain. The only difference right now is how the metadata are attached and where are you putting this data. In 7-to-1 case, the metadata were present in the mint call attached to the token. For 1155, the metadata are attached to the contract you are doing. And if you put the ID in the braces, in the URL, each client should automatically follow this standard and replace the ID of the token in this URL, and this URL will point to the specific token metadata. This is the way how it's being done. There's a question from Osama. Is the token transfer, for example, not need a provided permission? So anyone can have that API and Postman can do it? You can transfer only the token you own. So if you own the token, it belongs to a specific address, and the address and the ownership of the token is attached to the private key, which is used inside the transaction. So if the transaction is being signed with this private key, you are telling the blockchain that from address associated with this private key, you want to send that one token away. No one else can send your token away if they don't.
Can I add to that, Samuel? I think I know why he's asking. Osama, these are public blockchains which are permissionless. We set permissions in multi-chain because we are setting a permissioned blockchain or a hybrid blockchain. So I think that's why he was asking that question.
Yes. Okay, thank you.
These are public blockchains, so they're completely permissionless.
Okay.
Yeah, if you will work with Quorum or anything else, yes, you need to approve the transfer between. You need to approve the operation between it's being done. Yeah, but on public blockchain there is no permissions outside of the ones you will put inside your smart contract. And one of these permission is permission to mint. But this is built inside a smart contract, not inside the blockchain as such.
Okay.
Okay, so for 1155, as I said, we will deploy some contract again as abstract as in the previous one. We can reuse the transaction ID in the get contract address endpoint, get the address of the contract, and we can mint tokens. Let's mint token number 1, and we are gonna mint 10 pieces of token number 1. So we're gonna mint 10 copies of token number 1. So there's gonna be 10 NFTs on the blockchain. Each one is exactly the same. We will see in the Explorer, well, we won't, but we'll explain. We have just minted the data, and in the logs there is some information about transferring single call, something out there. Most of the block explorers are not capable of displaying the ERC-1155 standard easily. So the only way you can you can find that transaction is 1155 is to parse the events and logs from the contract. And in our case, we are creating new token number 1, 10 pieces of it, and sending in from 0 address, which means mint, to a recipient. That's basically what we see right now. Etherscan, Polygon Scan, they have like nice UI support for showing these ERC-1155 operations as well, but other chains not yet. But we have just created 10 tokens. Yes, Leopold, I'm going to the gas pump. No worries. So we have just created tokens. Again, another batch operation available for multi-tokens. You can mint multiple different token IDs with multiple different number of copies to the multiple recipients, same as for NFT. We can again transfer, we want to transfer token number 1 and 1 copy of that to someone else. Transfer multiple, we are transferring 2 different tokens from me to someone else, etc., etc., etc. All of these informations are there, and endpoints are there. So very similar integration to what we saw in 721s or ERC-20s. Please give me 1 minute. I'm gonna grab a cup of water, and I will show you the last thing I wanna show you today. Okay, I'm just right back. And I'm back. It was fast. So you can see like what we've covered is working with different type of NFTs, different type of ERC-20 tokens. You can see that the integration is very similar between different standards. That's what we've been trying to achieve. So like the concept is like familiar for you if you work with NFTs and ERC-20s. But as Leopoldo was asking, I'm gonna show you like the final stuff today, because I think it's a lot to cover. I'm gonna show you one very unique feature we have been working on for some time, and we call it the gas pump. As most of you know for sure, if you wanna transfer NFT or Elon 55 or ERC20 token from your account to another account, you need to pay a gas cost for the transaction because you are performing blockchain transaction. And to pay for the gas cost, you need to have the native assets present on your address. And that's very fine if you are like a random guy like me or you out there and you are working with your NFTs or your USDTs. But if you are building some like public application, for example, some custodial marketplace or some custodial wallet or even exchange, you need to take care of millions of different accounts in the system. You want to grow big, you want to be big. Your app will be used by hundreds of thousands or millions of people out there. And each of them will have their address. Each of them will receive some assets on their address. And you as a custodial like provider or custodial operator, you need to take care of these assets. You need to transfer the tokens on behalf of your user somewhere. I don't know, some withdrawals. Imagine Binance or Kraken or any other exchange out there. They just create a deposit wallet for you. You send their USDT, and you don't care what's happening internally in their system. You just send their 1,000 USDT. You have done some buy and sell. You have been successful. You just want to withdraw 10,000 USDTs you have earned from your trading, and you just say, okay, please withdraw 10,000 USDT, and they just withdraw it. They just send you 10,000 USDT away. But if you will think about what's going on inside, you have sent 1,000 USDT to some random address on the blockchain, and then you have withdrawn 10,000 USDT from some completely different address on the blockchain, and you didn't pay like Ethereum or Tron cost for these transactions. You just pay for USDT, and on Binance you would pay like $20 or $30 for withdrawal for like 30 USDT. And what's happening internally in their system is that they need to somehow transfer those deposit tokens you have deposited on some random address to their internal address somewhere, to their, let's say, managed hot wallets or cold wallets or something like that. And they have to do it not only for you, they have to do it for any other user they have. So if 1 million people will send 1 million USDT to 1 million different addresses in Binance, they need to perform 1 million transfers of these USDTs to their internal address. And as we have been, as we have said before, they need to pay the native asset they need to pay a gas cost, and they need to pay the native asset. So in order to send those 1 million deposits of USDT to their address, before they need to transfer Ethereum or any other native asset on any other chain, they need to transfer 1 million times 0.001 Ethereum to these million addresses. And only after that, they can withdraw and rebalance their internal balance sheet. And only that they can transfer those USDT away. So imagine what needs to be done. They need to send transaction in order to move those assets. And they need to do it not only once, they need to do it for every deposit you are doing. Or I don't know, it's based on their business, for example, once in a month or once in a week. But they have to transfer Ethereum somewhere in order to withdraw from that place to their side. And imagine they don't have 1 million users. They have much more than that. And they don't have only Ethereum, but they have much more chains than that on which they support these tokens. And it's a huge, huge, huge amount of money spent on these transfers, on these top-ups of Ethereum, which will be used for withdrawals. And not only a huge amount of money spent for the blockchain cost, but even more money spent on the operations. From the operations side of the project, they need to have a huge back office application where they track all these balances, what's going from which direction, where there is a lot of money which needs to be withdrawn somewhere, how much should they send there to withdraw because of the current gas price on the blockchain, etc., etc. There is plenty of people sitting there. There is a huge amount of development time used just for this back office stuff, which is not visible to the user, which is just necessary because you can't do it anyway. Well, you can. We have prepared some functionality which basically eliminates the need of topping up the native asset to the deposit address. And we can transfer any ERC token, NFT token, 1155 token from any managed address which was created in some like way, to transfer any token away, and the gas cost is being paid by a different address. So the native asset doesn't have to be present on the address from which you are transferring your USDT or your NFT, which means you get rid of all these transfer NFT there transactions. You don't have to do that at all, which means your back office logic could be much, much, much simpler. You don't have to look to different various scenarios and where I need to send money, how much, is there some dust spent, etc., etc. That's just not needed and required anymore. There is a question from Dave. Please can you explain how Binance and other centralized crypto exchanges manage multiple addresses from the different chains for one customer? I don't know maybe what you mean, but like my first guess where this question goes, they in their system they have some user or customer entity present, and they support, I don't know, Binance supports, I don't know, 200 blockchains out there. So they just definitely leverage these HD wallets I was talking today. They are leveraging these XPubs, and they usually use the same index for the one user on each chain. So they know that, for example, they own 50 mnemonics, they own 50 XPubs, and user number 1 will always have XPub number 1 on each of the supported chains, and they can know how to deal with that in their side. That's doable. On the other hand, some exchanges are using the similar principles as I'm going to describe in this gas pump in a minute. So maybe if you wait a little bit, I will show you how this is doable. But so regarding this special type of managed addresses we have created for you, it's basically a smart contract. What you do is you create a smart contract which is used as a deposit address for your application for one of your users. And this smart contract can accept any native asset, any ERC20 token, any ERC721 token, any ERC1155 token out there. And your users will just receive the tokens on this smart contract, and you from your side, from one private key, which was used for generating this special contract address, you will swipe these contracts and the assets present on it and everywhere and anywhere you want to any other address. But the fees will be paid by you and you only. So let's just do something right now. Let's create, in our URLs, there is always a custodial stuff present here because these addresses are usually used for custodial applications. That's just that. And from one private key, which will be used for every transaction cost connected to these addresses in the future, from this private key, I'm going to create 200 smart contract addresses out there on the Celo blockchain. And this is the owner of that address. It means from this address, you will be able to well, this address will be used for signing the transfer operation. So only this address can transfer asset somewhere else. And from this address, you will pay for the gas cost. But let's just deploy it. Again, transaction ID. Oh, I don't think I have the endpoint available here. We have, again, another handy utility to get list of the deployed addresses from the transaction. You can see that we have created 200 different blockchain contract addresses. When we take a look to the Explorer, you will see that this address on the blockchain is some contract. There's nothing present there. What we can do, we can use the Explorer, the faucet, and we will send some assets there to that contract. And I hope still working. Okay, something is showing up here. We can see that we have accepted on this address 5 Celos and 10 Celo dollar and Celo euro. Those are the ERC20 tokens. Celo is being used here as a ERC20, the native asset on the Celo chain, but that's a different story. But we have like 5 native assets here, and we have 2 different ERC20s available in this contract address. What we can do as well, we can, let's mint some NFT to my address. Let's mint NFT number 10. We can also mint some ERC 1155. Let's mint 10 pieces of token number 1. Perfect. So the balance right now should be, I have also 1 NFT. I don't see my 1155 here because the Explorer is not capable of showing that, but I have available here also the 1155 as well. So I have on this contract address different type of tokens. What I'm gonna do right now, yes, I will send you this Postman collection, no worry. What I'm gonna do right now, I'm gonna transfer from my managed custodial address some ERC20 token away. There is a custodial transfer operation, which is similar, or the endpoint is same for each asset you want to transfer. The only way where it differs is the contract type, which could be 0, 1, 2, 3. 0 is ERC20. 1, 2, native asset is 3. Everything is in the API doc, no worries. We are saying that we are working on a Celo blockchain. this is the private key connected to this owner address. So I can transfer the tokens only using this private key connected to the owner. I'm gonna transfer from custodial address FEP, where I have money. I'm gonna send it here. I'm gonna transfer this token, which should be, I think, USDC, yeah, Celo Euro, which is a Celo Euro token. So I'm gonna transfer Celo Euro from my address. Let's just transfer it. Okay, there is transaction, which is always a good sign. We can see the transaction is here. We can see, let's refresh. We can see I have only 9.99994 Celo Euro here. My native Celo is not like decreased. Anything else is present. And when we take a look to this transaction, we can see that the fee was paid from someone else. Yeah, from this 80 address, there was a fee paid, and tokens were transferred. The same applies if you want to transfer 7-to-1s. I'm going to transfer from this custodial wallet. I'm going to transfer my token number 10, and this is the contract address, right? So token address is always address of the token you want to transfer. Custodial address is always address from which you want to transfer. Recipient is recipient. This is the private key, so the owner of the custodial address. We are transferring token number 10. We are transferring NFT on a Celo chain. So let's transfer. And again, we will see that we don't have the 7-to-1 anymore present. Still have the 5 Celos here, and the transaction just transferred token number 10 from the custodial to someone else, and the fee was paid from the owner, not from the contract. Exactly same is gonna happen for 1155. Same approach, just use contract type 2. How many tokens, which token, how much of them, from which custodial address was the contract address of the token I want to transfer, who's the recipient, and the private key. Same here applies. So using this approach, you can totally eliminate the Ethereum top-up transfers of the deposit addresses in the blockchain. And when we think about how Binance, for example, could implement this stuff, they will create 200 batch addresses for 200 of their users. Each user has assigned a specific address. Yeah. This is mine, this is for Roha, this is for, I don't know, Osama, whoever. Each user has this type of addresses assigned. He can deposit as many assets as he wants. I can deposit on my address. I can deposit USDT, USDC, Chainlink on Ethereum. When we are talking about Ethereum, Chainlink, NFT, whatever out there, it doesn't matter. You just deposit anything. And the Binance, once in a while, just performs the swipe of these tokens to their internal address, and they will pay from their Binance main fee account. They pay the fees for this swipe of the tokens of my deposit address. That's basically how it works.
That's an awesome innovation, but it's very, very, very interesting.
Yeah, like this was this was very well accepted by our projects because you can imagine basically any custodial project out there is leveraging that. Anyone.
Awesome.
Anyone.
Awesome.
And as I said, this is available. Maybe I did not say that, but you can maybe expect it. This is available on any chain EVM compatible with supporting, so you can work with Ethereum, with Polygon, BSC, whatever out there. It's written in the documentation.
Amazing. I think we should now let Samuel take a break. He must be quite tired with such a long session. So whatever other questions you have, we can always take them next week. I'll try to answer them. If I don't, I'll get the answer for you guys individually. So Samuel, that was really amazing. I also got to learn a lot today from you. Thank you so much for your time.
Yeah, guys, if anything, guys, you can always reach me out on Telegram, or we have like the Tatum Telegram is present there. Discord for Tatum is there. I can send you a link to the chat if you want. I will send it right now. So you can join me there. I think it's like this. Yep, it's like this. Our Discord channel is also available. And you can ask any questions there, or maybe the questions were already answered, but you can find each of these links in our community page on our website. Happy to be here, guys. I hope I have learned you something, or at least broaden your ideas and what can be done on blockchain and not. And as I said, this is just the top of the iceberg, and there's so much more in the platform you can leverage.
Thank you so much. Thank you. Bye-bye.
Thank you, guys. Bye.
Bye.
Thank you.